1 through 4 is something that you've already learned, so let's review it together. Hey, I'm going to go because you said let's get through this. So one-to-one property for exponents. Your goal is to have the same base on both sides. Number 1 is golden. What do I do once I have the same base on both sides? How do I solve for x? 6x plus 1. Yep, 6x plus 1 equals 4x minus 1, and then you just go to town on a linear equation. So you need to group together your like terms. So subtract 4x to the other side. 2x plus 1 equals negative 1. Then you would subtract 1 from both sides. So you'd have 2x equals negative 2. Divide by 2. So x will equal what? Negative 1. So you just solved an exponential equation. You did not need logs at all. So I want you to remember these easier steps. We're learning logs today for the harder ones. Don't do the hard stuff on the easier stuff. So remember this strategy. Skip down to number 3. I've got an e on both sides. We didn't learn about that variable this year. You will see it in pre-calculus. But what does x have to be? If negative x has to be equal to 3, then x has to be how much? Negative 3. So number 2 and number 4 have different terms on each side. You need to make them both into the same base. So you need to know what power family they come from. They both happen to come from the 2 family, both up here and down here. If not, it might be the 3 power family or the 4 power family. You need to change 4 to the x into a power of 2. So you've got 2 to the x plus 7, and you've got 2 squared to the x on the other side. And the rule when you distribute exponent powers is you multiply. So this is really 2 times x. So now I can set x plus 7 equal to 2x so that I can solve the final equation. So because the bases are the same, you set the exponents equal. So what happens when you subtract x to the other side? Just 7 equals x. So the answer must be 7. So even though I don't know what 2 to the 14th power is, but 2 to the 14th power and 4 to the 7th power on my calculator must come out the same. So if you had a calculator on that section, you could always check that your answer makes sense. All right, these both come from the 2 power family, and they both need to get rewritten. How do I rewrite 1/2? 2 to what power? Yes. And then I've got that x sitting out there. And how do I rewrite the 4? We just did, right? 2 squared. Okay, on this one, you need to be careful with your exponents. I distribute here, and I get negative 1 times x. But when I distribute here, I have to distribute it to both terms. So I get negative 1x, or negative x, equals 2x plus 8. So a common mistake I see is that students don't distribute it to both terms. All right, so let's see. I would subtract 2x. I mean, you could have done this in a different order, but so I have negative 3x equals positive 8. So when I divide by negative 3, I get negative 8/3. Does that sound like the way that you approached it? Okay. So there's a one-to-one property for exponents. There's also a one-to-one property for logs. So this little number here is called the base of the log. And if the base matches on both sides, you can do kind of that same thing. This 10 has to be equal to this x plus 3. Over here, the base of the log is 10, so it's like the unwritten base. So I can take 10 and set it equal to x plus 3. I can take 3x and set it equal to 2x plus 2. So you're really just solving a linear equation. You don't need exponents and logs. You're just solving a linear equation. So take a minute and solve 5 and 6. We got 7 and 2. So now we're going to need to do a little bit more to solve these equations. Down below, we don't need to do anything besides remember from yesterday the powers of logs. So we're changing these kind of into exponential form in our head. So remember yesterday, let's see if there's one I can grab here. Take a look at number 13. Yesterday we went through a bunch of practice. Basically, if you have the base, you're asked 3 to what power will give me 1. So what does x have to be to make that a true statement? Anything to the 0 power will give you 1. So x would have to be 0. So this is understanding kind of how to rewrite this as an exponential statement. So number 13 is just 0 because 3 to the 0 power would give you 1. So I'm just using that as an example because I had the 3 and the 1. When we skip back up to number 7, see how we have the 3 and the 27 again? Now, I'm just going to think of it as 3 to what power would give me 27 in my head? 3, right? So that tells me that over here, the answer is 3. I have to figure out what x has to be to make that 3, right? Because 3 cubed is 27. What does x have to be to make it true? -2. So the answer to the log is 3. 3 cubed is 27. But x is part of that expression. X has to be -2 so that -2 plus 5 gives me 3 on this side. The log expression is really 3 cubed equals 27. But see how writing 3 cubed equals 27 doesn't help me solve that? On number 8, how would I change that one to an exponential expression? The base is 2. The power is 2, so 2 squared equals x. So if you rewrite them in exponential form, it's like this circular relationship. So if 2 squared equals x, what does x have to equal? Just 4. You just do 2 squared. So you rewrite it in exponential form and decide what part is missing. So in number 9, the base again is 2, the base of the log. 2 to what power this time will give me 1/2. So this number raised to this power is equal to the number inside. 2 to the x equals 1/2. Yep, so x has to be -1. So these are all solvable by the powers. But you have to know what a log is. So number 10, how would I rewrite it? X to the first power equals 4. Not quite on this one. So what number raised to the first power will give me 4? Just 4. You were thinking about the 1 being on the inside of the log. See how number 13, the 1 was on the inside of the log? This time 1 is the power itself. What about number 11? 6 squared equals x. So x just has to be 36, right? 6 squared is 36. Number 12, 2 raised to what power gives me 32? If you don't know, you've got the table as reference. I just count the 2's on my fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it must be the 5th power of 2. So x would be the 5th power. Why don't you try 14 and 15 on your own just for a second before we go to the back page? See if you can understand 14 and 15. All right, so for my sake of my video here, so did you get 3 and -3 as your two solutions? So you're starting to understand how the log relationship works. 3 and -3. Okay. Onwards. Where am I? Here we go. This one just says rewrite each equation in exponential form. I think you should already be able to do 16, 17, and 18, and 19, 20, and 21. Maybe not 21 or 20. No, 19 you could do. So 16, 17, and 18, what they want you to do is just write, hey, 6 squared is 36. I know how to go between log and exponential form. That's an essential understanding to be able to solve what's coming next. So 6 to the negative second power gives me 1 over 36. And this one is 36. We know that the square root, the 1/2 power, gets me 6. So on your test on this, there'll probably be a question where these are just like kind of random nonsense, like the log base x of a equals b or something like that, and I have you rewrite it in exponential form. Okay, x to the b equals a. So just knowing how to go from log form into exponential form when it's just random variables, m, b, x. Over here, it kind of makes sense because you already know that this is a true statement. So just knowing how to go between the two when it's just kind of random letters. All right, here are some that are a little bit more challenging, and then we need a new strategy when we get down below. So solve each log equation. Again, your first step is always to change it to exponential form. 5 squared equals x plus 1. So now I do 5 squared, so that's 25, equals x plus 1. What does x have to be? 24. Right. Subtract 1, x would have to be 24. 20 is a little bit different of a problem. So 20, what number squared is equal to 25? Oh, I guess that's not difficult, but what number squared would give me 25? 5. Technically 5 or negative 5, but for logs, our domain is always positive numbers because our graph, remember we looked at the graph briefly yesterday. I'm not going to test you on the graph without like an inverse, but so the x value always has to be positive as your answer. So x equals just positive 5. And this one is what number to the 1.5 power is equal to 8? Without a calculator, this might be kind of tough, but x to the 3/2 power equals 8. I want to show you how to do an inverse operation to both sides. You know how you would like multiply by 2 or subtract 5 from both sides? You can actually raise each side of an equation to the reciprocal fractions amount. So this, I probably would not put this on a test unless it was a bonus question, but it's really just asking you, what is 8 to the 2/3 power? Because a fraction times its reciprocal is just 1. So this is really x to the cube root of 8 squared. And some of you struggled on this part on the quiz. Taking the cube root of 8 and then squaring the result would give you what? 4. Right? 2 squared would give you 4. All right, we're getting there. Those were all power families. These are not power families. So there's no exact power of 3 to get to 72. So solve each equation by changing into log form. Remember how I said you need to be able to go between the two forms? All right, so which of these numbers is going to be the base of the logarithm? The 3. So whatever the base is for the exponent, that becomes the base of the logarithm. And remember, the power goes outside the equal sign and the other number goes inside the equal sign. I want to show you where this key is on your calculator because you have a log button on your calculator. It is right next to the number 7, but that is just a regular log with base 10. So if you just type in the log, it's not going to let you change the base. So you actually need to go to the math key and all the way down at the bottom, letter A, you'll see log base. So it's under math Go down to A, log base. Math A, log base. See, log base, it allows you to change the base to what you want and the inside the log to what you want. Log base 3 of 72, about 3.9, right? 3.89. Was everyone able to find that key? Yep, math, go down to the bottom and find that key. The log key is on your calculator screen, but that's log base 10. The natural log is also on your calculator screen. You'll see that in pre-calculus. So it was about 3.89 or 3.9. So we're going to do the same thing on 23 and 24, changing. It's kind of like we're taking the log of both sides. We're changing form into logs, right? You have no other way of solving this, right? Unless you did guess and check in a calculator. So the log base 2 of 43 is equal to x. And this is just kind of surface level understanding of logs this year, so that when you get to pre-calculus, you're going to go much more deeply into the log function with some complicated applications. So at least it'll be the second time that you've seen a log before. So you would just type the log base 2 of 43 in on your calculator. Log base 2 of 43. 5.43 if we rounded it. Was everyone able to get that? So can you try example 24 on your own? Okay, so everyone understands where that button is. Even if it was on the test, I could tell you math log or base or something. Okay, so the last two that I want to do, and then you've got guided practice to try when we come back in. Solve each equation by changing to exponential form. So first you need to get this log all by itself. So what would I move to the other side? What should I strip to the other side first, do you think? Least attached. I would add 5 first, personally. Because we're also going to have to, you just have to make sure you multiply by 2 on everything. I would divide by 2 at this second step. So you'd have log base 3 of x equals 3.5. The only time that you wouldn't move the 5 first is if the log was in parentheses. So if this was x minus 5 in parentheses, you would not be allowed to move it to the other side. So you're just going to do on your calculator 3 to the 3.5 power and see what you get. What did someone get when they did 3 to the 3.5 power? What'd you get? You did 3.5 as your power. That's what I got. I got 0.77. So it's the base is 3 to the 3.5 power. 3 to the 3.5 power. Three cubed is 27. Oh, okay. So the last one, what would I do first? What would I move to the other side? Subtract 1. So I have 3 log x equals 4. Divide by 3 on both sides. So I have log of x equals 4/3. So what good is that? So it says I have to change into exponential form. What is my base if there's no base sitting there? 10. So the common base for a log is 10, just like the square root is the regular index for that radical symbol. There's nothing written there. It's a base of 10, just like the Richter scale, earthquakes, it's a base of 10. So you're going to do 10 to the 4/3 power on your calculator and see what you get. What'd you get? 21.54. I think you might have typed, did you type that in 4 divided by 3 in your, okay, I think it's 21.54. So when we come back, we're doing the guided practice, and those of you that are out today can show that to me on Monday that it's completed.